Hello everyone. So friends, in our previous lecture, we saw an example to calculate the nth Fibonacci number, and we saw that how we can solve the problem using recursion, and we also saw that when we use recursion in calculating the nth Fibonacci number, the problem was solved, but the solution was very less efficient. So friends, in this lecture we will discuss that how we can identify that a particular problem comes under dynamic programming. So usually dynamic programming problem has few characteristics. So one of the characteristics is optimal substructure. So what do we mean by optimal substructure? So here you can see that a given problem has optimal substructure property if optimal solution of the given problem can be obtained by using the optimal solution of its subproblems. So which means we are given a complex problem and we want to solve that problem, and if that problem can be solved by breaking it down into smaller subproblems and using the solution of those subproblems and obtaining the solution to the complex problem, gives the problem a property known as optimal substructure. So in our previous lecture, we saw that how we can calculate the nth Fibonacci number, and we also saw that how we can solve the problem of nth Fibonacci number by using the formula as, if you want to calculate the nth Fibonacci number, you need to find the sum of its preceding Fibonacci numbers, which is fib of n-1 and fib of n-2. So here you can see the complex problem has been broken down into smaller subproblems, which again gets broken down into more smaller subproblems, which we saw in our last lecture. Therefore, as an example, we can say that if you want to calculate the nth Fibonacci number, we can calculate by breaking it down into smaller subproblems. Thus, this problem has optimal substructure. So in our last lecture, we saw that in order to calculate the nth Fibonacci number, we can use the recursion and we can solve this problem. So while using recursion, we saw that if you want to calculate, let's say, the fifth Fibonacci number, so here in order to calculate the fifth Fibonacci number, we break this problem into two subproblems by first calculating the fourth Fibonacci number and the third Fibonacci number. So we further broke this problem into subproblems, and similarly it goes on like this. So finally, when we reach to a point that a problem cannot be divided further, so we usually encounter the base cases, which is n is equal to 0 and n is equal to 1. And then using the result of those base cases, we solve the subproblems. Then we use the solution to solve the bigger subproblem, and doing this, we finally solve our main problem. So here you can see that this complex problem has a property of optimal substructure, where a complex problem can be solved by breaking it out into smaller subproblems and using its solutions to solve the main problem. So this one property, optimal substructure, helps us to identify that whether a problem can be a dynamic programming problem or not. So friends, in our next lecture we will see that there is one more property. Combined with this property makes a problem a dynamic programming problem. So we'll discuss that property in our next lecture. I hope you like this video. Thanks, have a nice day.